Hello guys, this is Tronics Energy and this is episode 2 of making the digital clock. No Arduino, no microcontroller, just pure logic. So yesterday we actually made, we actually connected the NE555 in a stable mode to the CD4017. So the NE555 acted as the clock of CD4017. So today we actually added another circuitry, and if you can notice, once this LED reaches its last output, let's check, it jumps this to the next one. You can see once it reaches the last output, it jumps this to the next one. So how does it do that? So let me just explain. Okay, let me just, yeah, like that. So today what we have added is another CD4017 right here. So we said that we are going to make a digital clock. So the digital clock, we want to group the second, the minutes and the hours in terms of in a way that we are going to use less circuitry to make the clock. So this first part of the circuit counts seconds. So the decade counter here counts seconds in terms of 10 seconds. It counts 10 seconds. Once it reaches its 10th second, it goes back to its first output. So this one counts seconds, just basically counts seconds. And once this one reaches its 10th output, it drives this to go to the next bit. So what we have actually done is that we have connected the 10th output from the first CD4017 to the clock of this CD4017, meaning that once this one goes to pin number 10, it's going to act as the clock of this CD4017, driving it from the initial output to the next output. So meaning that this one will be representing 10 seconds. This LED will represent 10 seconds, 10 seconds, 10 seconds, 10 seconds, and once it reaches the last second, the last 6th second, it will mean that 60 seconds are over, or 1 minute is over. So from here we can actually drive another maybe a CD4026, because that's what we're going to do next time. We are going to drive a CD4026 from here to count minutes. So this one counts seconds, this one counts seconds in terms of 10, groups the seconds in terms of 10 seconds are over, 10 seconds are over, 10 seconds are over, and once it reaches here, it will mean that 60 seconds are over, or 1 minute is over. So so this is CD4017. So how have we connected it? So in a way that once it reaches the 6th output, it goes back to the first output. So if you can notice here in this CD4017, the reset, which is pin number 15, and the clock inhibit, all of them go to ground. But right here we want that reset pin to be independent in a way that we are going to use it, because we want to reset everything once it goes to 60 seconds for it to start all over again, the cycle. So this yellow jumper represents the reset pin, pin number 15, goes to the collector of this BC547 transistor. Then the base is actually, okay, we are going to explain the base later. The emitter goes to ground. So the output of this once it reaches the 6th output, the next output, which is pin number 7, which is the 7th output, I've connected it to an inverter. These are not gate, it's an inverter. Once the clock, the counter goes to the 7th, the 7th output is going to go high, meaning that that high is going to be inverted to be low, brought in by this resistor, which is 2.6k resistor. Once it reaches this point, which is the base of the transistor, is going to disallow the reset from accessing ground, because the reset has to access ground at normal conditions for you to do your operations. If you just disallow it, then you have triggered it. Also, the collector of the transistor have connected it to supply, meaning that once this output of this connection right here is disallowed, it means that the reset is going to be connected to supply via the 10k, meaning that it's going to reset everything that you have in this CD4017, and you're going to start all over again from the first LED, or the first output. So that's basically how I've grouped this one in order for it to count 6 seconds, or 60 seconds are over, and for it to start all over again to the first output. So if I can just connect it again for you to see. So right now it's in the first group of 10 seconds, then it goes to the next one. So it's going to go like that up to the last LED, and once it goes to the 60th second, it's going to go back to the first second. You can see once it reaches the last LED, which is the 10th LED right here, it jumps this to the next output. So we wait the second white LED, and we continue to wait. It's in the second last LED. So this one means that 50 seconds are over, so we are waiting for 60 seconds. Okay, now 60 seconds are over. Now this 60th second we are going to connect tomorrow to a CD4026 right here, which is going to count minutes. So once it goes, then it starts all over again. So that's basically how the circuit operates, and that's what I wanted you to see today. So basically I hope you have understood how I've connected the two circuits together. Just basically connect the 10th output from here to the clock of here, and also add a reset circuit for it to reset once it reaches its 60th second. So thank you very much guys for watching. Please subscribe to Tronics Energy, and hope to see you next time. Goodbye.